Section 2.3 is the properties of functions. One definition is a secant line. A secant line is a line that connects 2 points, any 2 points on a graph. So if we have this graph down here and these 2 red points, then this line here would be the secant line between those 2 points. The way that we find the slope of a secant line, it's just the slope of, or the average rate of change, or the slope between those 2 points. If we want to find a general equation for the slope of a secant line, so we can find it between any 2 general points, then we use the difference quotient. So we talked about that in an earlier section, but this is the difference quotient down here. So here's some more words that we use to describe functions. One is increasing. So that means as x is getting bigger, y is getting bigger. So like this interval right here is increasing, this interval right there is increasing. Decreasing, as x is getting bigger, y is getting smaller. So down here this interval is decreasing. Constant means that as x is increasing, y is staying the same. So that would be like if you had a horizontal line. A local min is the lowest point in a certain interval. So in this graph over here, this picture over here, this point right here, this bottom, that would be a local min. A function could have multiple local minimums or no local minimums, depending on the graph. And then local maximum is the highest point in a certain interval, so that would be the top of this part up here. Again, a graph could have multiple local maximums or no local maximums. We can use graphing calculators to find or estimate local mins and maxes. If you use Desmos, all you have to do is if you have, let's say, a graph like this one up here, you have it all graphed, you type this in for y1, then you just click the local mins and local maxes and it'll give you the value. The maximum and the minimum is the y value. For a TI or a graphing calculator, make sure you watch the other video that describes how to find local mins and local maxes. Even and odd is another way that we describe functions. So for even functions, if you plug in opposite of x into the function, you would get the original function back out. That means that it's a y-axis symmetry. If you remember, our test for y-axis symmetry was plug in a negative x and you get the original equation back. Same thing with even functions. For odd functions, if you plug in a negative x, you get the opposite of x back. So if you remember origin symmetry, if you plug in negative x and negative y, you get the original function. That's the same thing as odd functions. The way that I remember is odd functions have origin symmetry. Can a function have x-axis symmetry? So we have y-axis symmetry with even, and we have origin symmetry with odd, but why don't we have x-axis symmetry? If a function has x-axis symmetry, or let's say if an equation has x-axis symmetry, is it in fact a function? No. No graph with x-axis symmetry would pass the vertical line test. They're not functions. So we want to test to see if these two functions are even or odd or neither. Unlike symmetry where you have to test all three, for even and odd you just have one test and you get one answer. So you don't have to do all 3 tests, or in this case 2 tests. In this case you only do one. So for even and odd, you replace every x with an opposite of x. So in the original function, every time you see an x, you're going to replace it with the opposite of x. And then you're going to simplify. 2 negative x squared is just 2x squared. Negative x is just negative x. Negative x cubed is negative x cubed, so that becomes plus x cubed. So we can factor a negative out of the denominator, and you get x minus x cubed back. So that means that we have a negative, if we pull that out to the front, times the original function. So we plugged in an opposite of x, we plugged in a negative x. This one just became back positive. This one had 2 negatives. We could pull it out in front. We get the opposite of f of x back. So opposite of x led to opposite of f of x. So O's go together. That means it's odd. You only need to test it once. There's only one test for even and odd. So you only need to do it once. Once you get odd, it can't be both even and odd. So now go ahead and pause the video and try testing g of x to see whether it's even, odd, or neither. So same test, everywhere you see an x, you replace it with the opposite of x. So I have 5 quantity negative x cubed plus a negative x. So you end up with negative 5x cubed minus x. So I pulled a negative out of both of them. But because it's an absolute value, negative of a value is the same as the positive of the value for the absolute value. So you end up with the absolute value of 5x cubed plus x, which is in fact g of x. So you plugged in the opposite x and you got the original function back out, so that is an even. So whenever you're doing even and odd, there's only one test. You just plug in the opposite of x and see whether you get the original function back out, in which case it would be even, opposite the original function back out, in which case it would be odd, or neither of those would be neither.